All right. What up, guys? I apologize for not being there in class today. We're playing out of the baseball field if you can come out and watch. But we only allow 210 people. But we're going to be going over the rest of the properties of circles today. It kind of sounds like a daunting task, but it's really not too bad. And we'll move through them pretty quickly. I have an assignment for you guys afterwards. It's not like a traditional assignment. It's more of like it's almost like a puzzle. It's a circle with a bunch of chords and segments and secants and tangents and all that good stuff, and trying to find those angle measures. And you'll be able to see it afterwards. But we're gonna go ahead and jump into the rest of these properties. We'll get going, and then afterwards I'll explain what we'll do on. When am I gonna see you guys again? Monday. We'll go over on Monday. Then we'll go over the last thing on Monday, review on Wednesday, test next Friday. So, about a week till the test, but not too bad. All right, let's jump into it. The name of this unit is, or the name of this lesson is, The Rest of Circles. Okay, we're going to start with inscribed angles. So inscribed angles are angles on the with a vertex on the edge of the circle. Key thing being here is that the angle itself, right? So if we're looking at this angle itself here, right, is going to be half of the arc measure, right? So for example, if this angle was like 25, the arc measure would be twice what this angle is. So that would make this arc measure 50. Okay. This also works in reverse, right? If they give you a circle and they say like the arc measure is 80, right? That would mean the angle is half of that. So that would make it 40. That's a super important concept to have for this. We're going to be looking back at it the entire time. There are a few like quirky rules about this, right? If your inscribed angle intercepts the diameter, right? So the diameter is where the two endpoints are, right? It cuts across, okay? What that means is that your inscribed angle is automatically going to be a right angle, okay? So if it goes to the diameter, right? So this angle here has the endpoint here at A and here at C. That means that this angle B has to be a right angle. If you have overlapping arcs, okay, so what that means is if you have two inscribed angles that intercept the same arc, aka they have the same endpoints here, right? We have A, B, D, and also we have A, C, D, right? So they both intersect this arc of A, D here, right? So that can be a little bit confusing, but the overlapping arcs, if they share those endpoints, right, then those two angles are going to be congruent, right? So like if you were given this information, right, and say they said this was 60 degrees on this measure, well, you could say, well, this is an inscribed angle for arc AD, so it would have to be half of 60, so that would make this 30, right? And then this concept is saying, well, if ABD is something, it's going to be equal to ACD. So if this is 30, that means this also has to be 30. Okay. So we'll practice with those some more here in a second as well. And then the final weird rule is inscribed quadrilaterals. So if you have an inscribed quadrilateral, the quadrilateral inside the circle, all the vertexes are on the edge of the circle. Its opposite angles are supplementary. And just remember, supplementary just means 180 degrees. Okay? So, for example, angle A and angle C will add up to be 180. And angle D and angle B will add up to be 180 as well. Right? And this only works with quadrilaterals. Okay? So like pentagons, hexagons, all that stuff, that doesn't apply. Just your opposite angles end up being supplementary. Okay, so let's look at a few examples with those things we're talking about here. Okay, So the first thing is they would like give you a circle and they give you a few pieces of information and they want you to find the rest. Okay. So the first thing we're looking at is this angle STR, right? So it's looking at this angle right here. Okay, STR. What I first notice about that is that it has this arc length from SR, right? That is connected with it. And what we just talked about a second ago is that this angle is going to be half of whatever this arc measure is. Okay, so if SR is 106, then STR has to be half of that, and half of the 106 would be 53. Okay. Next thing we look at is QRS, right? So they're looking at this angle right here. What I notice about that is that Q and S are both endpoints on a diameter, right? So that's this thing here we were talking about. If it intercepts a diameter, that angle has to be 90 degrees. So QRS has to be 90. Okay, which helps us find this. So if this is 65, right, this angle has to complete the rest of the 90 degrees. So that means TRQ would have to be 25. Okay. And that's just like kind of getting ahead, right? Next thing they want us to do is find this measure of TQ, which goes along with that, right? So TRQ is an inscribed angle with TQ as the measure of the arc. Okay, so if the angle is 25, that means TQ would have to be 50, right? Twice what that angle ends up being. Next thing, and we're just going to keep powering through it, right, is SQR. Okay, SQR, just like STR, has SR inside of it, right? So if I'm looking here, right, SQR has this arc measure, right? So that means this is going to be half, which means this is also going to be 53. Next one would be ST, right? So we're looking over here at ST. Golly, I can't draw a... There we go. ST is inscribed by this angle here at 65, which means this has to be 2 times 65, which gives us, what, 130? Yeah, 130. And then finally, right, so we said this was 130, and this was 50. Okay. And then QR, your final measure here, we can figure out in a couple different ways, right? We know the whole circle is 360 degrees. We could also figure out what this angle here would be and double that. But the easiest way to do that is just to take up the rest of the measures, add them up, and then subtract them from 360, right? So if I took 130 plus 106 plus 50 plus, say we said this was X, right? Plus X equals 360. We can add all of these up, subtract it from X, and we end up getting 74. Okay, so QR would end up being 74. Reason being, once again, the circle makes 360 degrees. We know this is 106, this is 130, this is 50. So then QR would be that last missing piece that we would need to add. Okay. The next one we're looking at is this here. They give us a inscribed angle at 71, and then they give us the measure here is 16x minus 2. Well, what I could say is 16x minus 2 is equal to 2 times 71, right? Which you could divide this out, right? So we could get 8. We could just divide everything by 2. We get 8x minus 1 equals 71, right? We could add 1, add 1. We get 8x equals 72. Divide by 8, divide by 8. So x would equal 9 on that one. Okay. Here, right, if they don't give you any variables, or sorry, they don't give you any measures, but we have something with variables, we can still solve that, right? We could say that this arc measure, so 5x minus 27, is equal to 2 times the angle measure, which is 2x minus 5, right? We could distribute this out. This becomes 4x minus 10. So 5x minus 27. Then you can move the 4x over. We could add the 27 over. We would get x equals 17. But do pay close attention. It wasn't just asking us to solve for x. It was asking for the angle measure EC. So then we have to take that x and actually plug that in. Right? So we'd have to take 5 times 17 minus 27. And that ends up giving us 58 degrees. And I cheated and I solved this all earlier. So I'm literally just looking at my old notes. And that's why, obviously, I don't expect you guys to just go, oh yeah, 5 times 17 minus 27. Obviously 58, right? But you do have access to a calculator, and it should be relatively easy to do that. And then the final one is looking at the quadrilateral. They tell us this angle measure is 11x minus 29. And this angle measure is 6x plus 5, right? Because they're opposite angles of each other, we know that if we added them, it would have to equal 180 degrees. Okay, so we can combine like terms. 11x plus 6x gives me 17x. Negative 29 plus 5 equals negative 24. Equals 180. Plus 24. Plus 24. 17x equals 204. And everybody knows 204 divided by 17 is 12. Okay, so once we find x is 12, then they're looking for a measure of angle W. So then we just have to plug that in. 11 times 12 minus 29, which ends up giving me 103. Boom. So that's using all of our interior angles. And that covers all of those bases. All right, so the next thing we're going to look at is the interior intersections when we're talking about angle measures. What this states, when these two chords or secants cross on the interior, the angle of measure, or the measure of angle 1, is going to be half of the inscribed arc plus the opposite arc when you add those together. So half of that. And then the same thing for measure of angle 2, right? So you're going to add the arc length that is just on the outside of that, and then what's opposite of its vertical angle as well. So like, for example, if they said this was like, I don't know, this was 50 and this was like 72. Okay, I'd have to take 50 plus 72, right? Which gives me what, 122? And then divide that by 2. So that'd give me what, 61? Right, so angle of measure 1, if those were my given measures, right, would be 61. If they intersect on the circle, right, which would be a secant and a tangent, it's just, if the measure of angle 1 would be half of its arc, right? So from A to B to C. Okay, it would be half of that arc. And then the measure of angle 2 would be half of its arc, right? So C to A, or A to C, however you would want to write it. So like, for example, if they said this arc was 220 degrees, right? Angle 1 would have to be 110. Kind of like what we were just talking about with the inscribed angle, right? It's just another way to write it. Now, if they meet on the exterior, so this one's if they meet on the interior, right? They cross on the interior. This is if they cross on the edge of the circle. And then these are your situations if they cross on the exterior. right? These all meet outside of the circle, okay? And the concept remains the same for all of these. They're just a little bit different. If you have two secants, right, so they cut through the circle, you're just going to take half of the two inscribed arcs, right? The arcs that are in between the angles. But you take the bigger arc and you subtract the smaller arc, and then you take half of it. Okay, and that's really the case for each of these, right? You take the bigger arc and you subtract the smaller arc. Right, say that one there. And then same thing here, right? We would take the bigger arc and subtract the smaller arc. And then multiply it by 1/2 or divide by 2, however you want to think about doing that. But that's when it intersects on the outside. So if it's on the inside, we add the arcs and divide by 2. If it's on the intersection, we just divide by 2. And if it's on the exterior, we subtract the arcs and then divide by 2. So those are kind of easy to get mixed up, but we're going to practice with them a little bit more. Okay, so like here, if they're asking you to find the angle of, the measure of angle 1, okay, I end up having to take 153 plus 105 and then divide that by 2. 153 plus 105, where's my notes from earlier? So I can just power through this. There you go. Ends up being 258. 258 divided by 2 gives you 129. So the measure of angle 1 would end up being 129 degrees. Okay. Here, if they're wanting you to find Km, right? There's a few things that we could do. First of all, the easiest thing would be to find this angle measure here, because it's part of this supplementary angle, right? Because it's a straight line across. If this is 133, then this angle has to add up to be 180. So we can take 180 minus 133 gives me what? 47. So this angle measure ends up being 47. Okay. So then I can use the same concept we used over here and say, well, 47 is going to be equal to 67 plus something, right? We don't know what that something is, divided by 2. From there, you could multiply both sides by 2. You get, 94 is equal to 67 plus x, subtract 67. And you end up getting x is equal to 27. Right? Does that seem right? Yeah, 27. So, measure of Km would be 27. Here they're asking about finding Wx, right? So they're asking about this arc measure here. To do that, I've got to determine what this angle is. Same way we would determine this, right? We take 180 minus 138, okay, which ends up giving us 42. Okay, so if this is 42, we talked about if it intersects here, right? This measure is going to be twice what the angle is, right? So like if this was 110, this would be 220. Same thing over here, right? If this was 40, this would be 80. Okay. So if I know this is 42, then the measure is going to be 2 times 42, which ends up being 84. So the measure of arc WX ends up being 84. Okay. Here we have one example of each of the other ones we were talking about. Here, if they want me to find the measure of E, I have to take the bigger arc minus the smaller arc and then divide by 2. Right? So 141 minus 25 is 116. Divided by 2 ends up giving me 58. And then same thing here, right? I have to take the bigger arc and subtract the smaller arc. So 219 minus 89 divided by 2. Okay, 219 minus 89. Oh, sorry, is going to be equal to us. I didn't see that they gave me this. It's going to be equal to 4x plus 1. Right, so they're wanting me to solve for x. So if I solve this, this ends up giving me, I think, 65. Yeah, 65. So 65 is going to be equal to 4x plus 1, because subtract 1 over. We end up getting, I'm going to do it over here, right? 64 is equal to 4x divided by 4, divided by 4. We get 16. All right, so x would be equal to 16. Then on 28, we have two tangents, right? So it meets on the edge. We end up having to find, right, if this is 107, right, we have to think, well, what's going to make up the rest of the circle? Right, we know a circle is 360 degrees, so I essentially have to do 360 minus 107 to figure out this major arc length, and that gives me 253. Okay, so then I take my bigger arc of 253, subtract 107, and divide it by 2. 253 minus 107 gives me 146. 146 divided by 2 would give me 73. So measure of Q would be 73 degrees. Okay, key here being recognizing exterior versus interior. And just remembering, interior you add the arcs, interior you add the arcs, exterior you subtract them, the big arc minus the small arc. And then if it's on the exterior, it's just like our interior angle, or yeah, our inscribed angles, same concept, half of the arc length on those. Okay, the last couple things is talking about segments. This first part's super easy, right? Is essentially A times B is going to be equal to C times D, right? So if we're talking about the interior segment lengths, right, those are usually pretty straightforward. The exterior ones can be a little bit more confusing, and they have a little bit tougher rules. If you have two secants, right, so things that cut through the circle, you have to take what's on the outside and multiply it by the entire length, right? So A plus B is going to be equal to what's on the outside, what's on the exterior here, times its entire length, right? So in this case, it would be C plus D. If you have one secant and one tangent, okay, you have to take the tangent length and square it, right? So A squared is going to be equal to exactly what we did over here with the secants, right? What's on the exterior times the entire length of that secant. Okay, so we'll have to take a look at a few of those examples. The interior ones are mostly pretty straightforward, but the exterior ones can be a little bit tougher there. So there's 6 practice problems on this one. The first one, right, we take a look, we'd have to do 21 times 10 is going to be equal to 14 times x, right? 21 times 10 ends up giving me 210. Is going to be equal to 14x. 14x. So divide by 14, divide by 14, we end up getting 15. Okay, once again here, right, we can take 6 times x minus 1. It's going to be equal to 4 times x plus 2. Okay, so we get 6x minus 6 is going to be equal to 4x plus 8. We can move some stuff over. Minus 6x, minus 6x, minus 8, minus 8. Ends up being, what's that, negative 14? Yeah. Negative 14 equals negative 2. Divide by negative 2, divide by negative 2. x would equal 7. And then if they were to ask like, oh, what would be the whole entire length, we could just plug that in. Okay. The next one, right? These are when we start getting to the exteriors and having to identify, okay, are they secants? Are they tangents? What do we use? Okay. This example is 2 secants, right? Because they both cut through the circle. If I'm trying to solve for x, right? The first thing, right, if we look back, is going to be exterior times the entire length. Okay, so the exterior is 7. The entire length would be x plus 7. So x plus 7. It's going to be equal to the exterior times the entire length. So 13 plus 8 would be 21. So times 13. That gives me 21. This gives me 7x plus 49. Okay, we would end up subtracting 49. Wait. Why am I adding it? Question mark. Slow down. Pause. The entire length is 21, so I need to multiply 8 times 21. Getting ahead of myself. So 8 times 21 ends up giving me 168. Yes. And then I can subtract 49. Subtract 49. 7x equals 119. Divide by 7. Divide by 7. X would equal 17. This is why I'm glad I solved these out ahead of time. Oh, I can look back at my notes. Okay. Looking here, right? Same concept, just a little bit more complicated, adding some more variables in there. But the concept remains the same. The exterior times the entire thing. So 4x minus 1 plus 7, that would give me 4x plus 6. Okay. Then I take what's on the exterior, 9, times the whole thing. So x plus 2 plus 9 would give me x plus 11. Right? We end up multiplying this out. We get 28x plus 42 equals 9x plus 99. Okay. We can move 9x over, move the 42 over. We get 19x is equal to 57. Right? We do that by minus 42, minus 42, minus 9, minus 9. And then we get x would equal 9. Okay. One more example here of that. Let's see. Did I not have one more example? I guess I had. That's fine. I'm fine with this. That's fine. Okay, so one more example of this, and then we'll have one final example here. So here I would have x times the entire length would be x plus 3. Then here I would have 4 times the entire length, which is 10. Right? So we get x squared plus 3x would equal 40. I can move that 40 over. Right? So now I'm dealing with a quadratic. Equals 0. So now I can find factors of negative 40 that add up to give me positive 3. Those factors end up being positive 8 and negative 5. Positive 8 times negative 5 gives me negative 40. Positive 8 plus negative 5 gives me positive 3. So my factors there end up being x plus 8 and x minus 5 equals 0. Right? Our final step to solve that is to set them equal to 0 and actually solve. We get x is equal to negative 8 and x is equal to 5. Now we're talking about distance, so we can't have a negative distance, so it can't be negative 8. The only possible answer would be x would equal 5 on that one. That one goes all the way back to last year when we talked about factoring quadratics. And then the final one, final one that we're going to talk about today is when you have a tangent. One where you have to set up the length of your tangent squared as equal to your exterior times x plus 16 times the whole entire thing. Okay. So then there, where were we? 20 squared is 400. Okay, and this ends up being 16x plus 256. We can minus 256 over. We get 144 is equal to 16x. Therefore, x would be equal to 9. Okay. Other than that, that covers everything for the rest of the properties. Okay, I can switch back over to this. Okay, that covers the rest of the properties. Next class, we're going to go over the final thing for circles, which will be graphing them, which sounds scary, but they're really not too bad. Okay. I'll be sure to post this as well as just the completed notes for everything that we've talked about so far onto Google Classroom. I'll post the worksheet probably right after this, right after I get the video uploaded. And I'll be excited to see you guys on Monday. Hopefully you'll have a great Thursday. Enjoy the rest of your weekend. Make good decisions. And then I'll see you all on Monday. Peace.